Okay, so earlier in this problem, you had to use function notation to define, let's go back here, the distance that each driver traveled in relation to the number of hours since the race began. Okay? And they said use t as that number of hours since the race began. So for that, we'll use c. Come on. All right, so for Tony Kanan's distance, since the race began, I'll use the function named capital C. And they said that our independent variable was t. So that will represent Tony Kanan's distance traveled in t hours since the race began. And then u for Al Unser, u of t. And it said the race ended when the winner crossed the finish line. So our domain for t is going to be greater than or equal to 0 and less than or equal to how many hours for the winner to cross the finish line? Well, that was Tony Kanan, so 2.667616 hours. So there's our domain for the independent variable, and then here's our function notation for each of these. Okay, so this whole problem, you're using C of t and U of t to define different values of quantities, and we never knew what the rule was, right? We never know what the rules for these functions are, but we can use that function notation because we've defined the input variable, the independent variable, and the dependent variable, okay? So now you want to talk about 8 and 9. So 8 said, what's the distance between, let's see, the distance between Kanan and Unser at every moment from when the race began to when it ended. So the distance between them is going to be what? So who won the race? Kanan won the race?
Yes.
So we can say that the distance between them was how far the distance Kanan was since the start of the race. And then to get the amount of distance is going to be the difference of their two distances. So that would be the distance between them. For the times t such that C of t is greater than U of t, or Kanan is ahead, we get a positive value. And for any times t such that if Unser was ahead during the race at any time, then this would be a negative value. Is it okay? It says the distance between them. So do we want to allow for positive and negative or not? If it's just purely distance, if you just want a distance, then that's a positive value, right? So how could we then make this? Yeah, so we would need, if we want this, the distance between them as a positive distance between them, we need that absolute value, because if Unser ever gets ahead, that difference will make a negative value. Now, if we wanted to find the quantity how far Kanan is ahead of Unser at any time t, then we can argue that negatives would be fine. So if we just left off the absolute value, then we could say this is how far ahead Kanan is of Unser. And so when he's behind, it's negative, and that's okay. Because he's a negative amount ahead, right? So that would be how far Tony Kanan is ahead of Unser at any time t. This would be their distance between them at any time t. Cool? Is that good? All right, so then, what about represent those times when Unser was ahead of Kanan? So what about the comparison of C of t and U of t if Unser was ahead of Kanan? Well, it would simply be that the distance that Unser has gone is greater than the distance that Canaan has gone. So we're representing that for any given time t, the value of u of t is greater than the value of c of t. Okay, so for all of you that represent or requested 8 and 9, how did that clear up your confusion? Follow-up question, yeah.
For 9, how is it greater if it covers the same amount of distance, but it's just less than 9?
Okay, but this is a function, right? So this is giving us all the different distances at any given time since the race began. So not just the final distance. This is a function, meaning it's a set of ordered pairs. Time equals 1 second and the distance, Unser traveled. Time equals 3 seconds, or 0.3 hours or whatever. So this represents every single distance they covered at every single time. So this is for which times was Unser's value greater than Canaan's? Good question. Yeah.
So with the earlier question with number 8,
yeah.
The absolute value sort of
yeah.
Took into account the fact that when, say, Unser does get ahead of
yeah.
Canaan.
Yeah.
This one, like, Unser isn't necessarily ahead of him the entire time. Why is it okay to just leave it as that's like shouldn't there be some way to account for it? Shouldn't we have an equation? I just thought we'd do some sort of equation like one.
But Unser wouldn't necessarily have to always be ahead because nobody said that they agreed that both of them were going constant speed the entire race. Correct?
Okay, so what was your question?
It's just like the statement in 9. I don't know, just the way I'm looking at it. It just looks like Unser's always ahead. Like the value of his distance is always greater. Like
So
is there some way to account for that?
all t such that if I said all t such that this is true. So this is like, it's kind of like true or false. T can be all the values from the start to the end of the race. But we're saying for which values of t is that true? Is that better? Okay. And that will only be a subset of the domain, right? It'll be maybe in this little chunk of time, and this little chunk of time, and this little chunk of time. Yeah. Okay, good questions. Any more to ask? All right, let's see. How long do we got? We got 25 minutes. Let's work on some GC. So if you've got your laptop, open it up, open up GC. If you don't, if you can find someone to share with, so that means those who have GC, please be sharing of someone around you who might not have a laptop. So everyone can see one and is involved in the activity. Yes, I did. Thank you. Okay, here we go. Just make sure. Yes, we are rolling. Okay. So here's a formula. Okay, the cost of materials in dollars for a certain rectangular box with base dimensions L feet and W feet is given by this formula. Okay? Find the materials cost of the boxes with the following base dimensions. So we're going to kind of go through this in some different ways that we could do this. The first we've already seen, just direct calculation. So I could just come up here and say, oh, the first box is 4 times the length is 8 times the width is 4 plus 288 divided by the length plus 96 divided by the width. How did I do? Did I get that first box correct in the formula? Does it look okay?
Wouldn't you have to put parentheses around 4 times 8 times 4?
No, because multiplication comes before addition, right? In the order of operations. Yeah. So if you were adding first and then you wanted to multiply, we'd need the parentheses. But the multiplication will go before the addition. Okay, so what does this tell us? It tells us that box that's 8 feet by 4 feet would be $188. Piece of cake. I already did this, right? So this is just using graphing calculator as a calculator on values. Just put an expression in with numbers, it cranks out your answer. Okay, so next. All right, so another way to do the same thing would be using what we call parameters and formulas. So I can set up this thing as a formula, okay, as a formula. And so I want to show you how you can use character strings as parameters and variables. And to do that, you're going to hit backslash, the true backslash, which is above your return key. Okay, you see that? That's backslash because it's leaning back, okay? Backslash. And then type in the character string that you want to make a single variable or parameter, so cost. And then hit it again, hit backslash again, and what you'll see is that the backslashes will disappear. And now that capital C-O-S-T, now GC recognizes that as a single variable or parameter. Okay? Notice it says equals 1. Any parameter that you're going to use or you define, if its value is not defined, then by default it will get the value 1. So right now, cost equals 1. But what do we want cost to be? We want it to be this formula, so we're going to... So cost equals 4 LW plus 288 divided by L plus 96 divided by W. Okay? So why doesn't it give us a value? Well, because this line is just defining the formula. Now if we want a value for cost, we can just, in the next line, type in capital C-O-S-T. Now, how did it give me the value 388 for the cost? What does that mean, 388?
It's defaulting the other values.
Right, so what box is this calculated?
L equals 1, W equals 1.
Right, this is calculating now, because we haven't defined what L and W are, it's giving us the cost of a 1 by 1 box. You see that? L is 1, W is 1, right now, because we haven't defined it otherwise. Yeah?
I'm sorry, I didn't catch what you did after you put in the formula.
I started a new command line and I typed in cost.
Okay.
Okay, so what do we want? We want the cost for that first box when capital L equals what? Capital L equals 8. And you see now, look what happened. The cost got updated in that second line. And then capital W equals 4. And lo and behold, we get the cost of an 8 by 4 box, which we know is right from what we did before, just with the numbers, right? Okay, does it make sense? Yes, sir?
You don't have the backslash for L and W, right?
No, if you're going to use just a single, right, exactly. If you just want a single letter to represent a parameter or variable, no backslash is needed. It's only when you want to do a string of letters to mean one variable or parameter. Backslash, write out the string, backslash. And then throughout the whole rest of the, if I wanted 2 times the cost, I don't have to use the backslashes. When I type cost now from now on, it just knows that that's cost. I don't have to use the backslashes, only the first time. So what's twice the cost? $376. Okay, so that's the idea of using a formula with parameters. So then I could easily come to the second box and I say L equals what? 2.6. W equals 5.9, and what automatically happens? It updates, and that box is only 40 cents more than the first one. Okay? Just kind of a weird thing that worked out that way. Dimensions are much different. That turns out just to be about the same cost, but only 40 cents more. Okay, so regarding constants and parameters and variables in GC, can you read that? I'll make it a little bit bigger. I'll see if I can make it bigger. Some letters are reserved. You don't want to try to write this down, okay? Just don't try to write this down. Some letters are reserved for special uses, so you can't use them like we were using capital L and W and capital W, right? Those are called what's like called free parameters. You can use them if you wish or not. But these are reserved. So X and Y, we know those are reserved to represent values on the X and Y axes, or it's the command, using X and Y prompts GC to graph, right? Z similarly will prompt GC to graph in 3 dimensions. X, Y, and Z are a 3-dimensional graph. Okay, R starts with the radius and polar coordinates, theta and phi, reserved for graphing in these other polar, cylindrical, spherical coordinates. T is reserved as a parameter for a parametric variable. Don't use it as a constant, okay? So watch out for lowercase t. You can use uppercase t, that's fine. Also lowercase u and v are reserved for plotting 3D graphs. We won't be using lots of this, but you want to make sure to avoid it is what I'm saying. So like avoid t, u and v, avoid these if you're going to use defined variables and parameters. Okay, and then also lowercase n. Did we do the slider in here yet? Yeah, so n is, whenever you use lowercase n, that'll open up that automatic slider. Okay, so you might want to avoid that as well. That's what you want. So you want a slider. Yes, sir?
Is it possible to have more than one slider value?
Yeah, you can define lots of sliders in it. Yeah. You just define other sliders besides n in, you have to define them in command lines. Yeah. Okay, so what are we going to use? We're going to use X and Y for sure. Note that that's what plots. We won't be using Z in this course. So yeah, so you want to avoid all these things I'm circling in blue. Avoid R, theta and phi, T, U, V, and only choose N if that's what you want. If that's what you want us to invoke a slider, okay, which we may do that. Okay, so now the third way of doing the same thing that we did before. Would be using functions, right? And this is the best, right? So the way that Graphing Calculator interprets and uses function notation is just like what you're learning in the textbook. Okay? So I'm going to just erase everything out here. So we'll start from scratch here. And so instead, let's say we want to define a function whose dependent variable is cost. Okay? So let's just call that, or let's practice setting up that. Just call it capital C. Just call it capital C. All right. So capital C will be the name of our function. Now, to get the parentheses for function notation, you don't want to do shift 9. Okay? Because if you do shift 9, it's going to think you want to multiply. So for function notation, you want to do control 9. Control 9 gives you the parentheses for function notation. As opposed to C multiplied by what's inside the parentheses. That would be if you use shift 9. All right? So now we just have 2 independent variables instead of 1. So we're just going to put them L separated by a comma. So it's the same as all the functions we've talked about so far. It's just that there's 2 independent variables rather than 1. And so now we'll define that function as, for the rule is 4LW plus 288 over L plus 96 over W. Okay. Did Graphing Calculator graph it for us? Did it produce a displayed graph? Nothing happened on mine, okay? Why not? Should it have? Should we have gotten a displayed graph when I defined the function?
You need an X and a Y value.
I need X's and Y's, right? X's and Y's, okay? So because we have two independent variables, we don't want to graph this one. It would take a three-dimensional graph to do it, so we'll avoid that. But in general, to graph a function, we're gonna invoke X and Y to do that. So we'll see that later. Okay, so now, how can I represent? I just want to represent the cost of a box with length 8 and width 4. How can I represent it? The cost of a box with length 8 and width 4. Who's learned something? How can I represent the cost of a box with length 8 and width 4? Yeah. C of, and you remember control 9. Control 9, 8, comma 4. And look, it knows that represents the cost of the box with length 8 and width 4, and told us what the value was. So this is how powerful function notation is, because what is C8 for? It's the value of the dependent variable. When we got the first, our independent variables have values 8 and 4. So here we're just quickly 2.6, comma 5.9. And then we got the cost of that box, and then we can go 10 and 7.25, and we get the cost of that box. It's bigger, so it's more expensive. Okay, any questions so far? So, graphing calculator works with and interprets function notation the exact same way as what we're learning in class and in the textbook. And that becomes a very useful tool when things get complicated. You've got big formulas. To be able to use function notation in other formulas makes things a lot clearer and easier and efficient. Okay? So that's why we're really working on this function notation. So here is this is a little exercise for you. Can you read it in the back? Is it big enough? I see nods. Okay, great. The height of a sunflower is modeled by the function h of t equals this rule, where h of t is the height of the sunflower in centimeters, t days after the seed germinates. The function is only valid for the first 10 days after germination, so this is what? The domain of the independent variable from 0 to 10. Okay, so I want you to work through this. Hopefully we can get through this in 10 minutes. All right? So these first two questions are just general questions, and then C starts you working in GC. Okay? Go. Work efficiently so we can get done. Okay? Yes, and I told you that. No, I tell you, just follow the, just go through the instructions. Just work through the problems. I point that out. Okay, don't spin your wheels. Get off to a good start. Here we go. No, you don't have to. Now, when you get to graphing it, then you're going to want to graph before that, so I'll show you how to do that. Okay. Oh, okay. Oh. We didn't get it with them. You should be on the graph by now. Don't use little t. Don't use little t for variable. That's why I specified something else. One got a graph. How about this? Will this graph it? Why not?
There's no X value.
In that second line, what does it think little a is? Well, what does it do? If you haven't defined a free parameter, it considers it to be 1. So it's going to put 1 in there, it's going to graph a horizontal line at y equals whatever you get when you put 1 in that. You're just going to go to horizontal line. Ready? There it is. Why? Because little a in GC's mind is 1. And so you're asking it to graph y equals whatever this turns out to be when a is 1. So it's just a number. So you're just going to, so how do I fix this? Yeah, if I replace the a with x, okay? And then we'll get the graph. But, all right, so that's better. But this isn't the way we want to do it. We want to take advantage of the fact that we define the function. We define the function h, and we want to graph the function h. So we don't want to spend the time of typing in the rule again. So instead we can do y equals what? What? Okay, I heard h of a. What do we think? Is it right? What will that do? What does it think little a is? 1. It's going to plug 1 into the function and give us that same line again. So what do I need? I need every value of the dependent variable for every x. For every x that you could plug in. So I do x. Mathematically, this is correct, right? We want to graph the dependent variable h of x as the y-coordinate for every x-coordinate as the independent variable. Okay, and then we want to do that from 0 to 10. So we do comma, 0 less than x less than 10. Or you can do less than or equal to, too. Okay, now let's get a better view of this. I'm only showing here from 0 to 5. So I'm going to get a better view of this. I'm going to zoom out a little bit. Why didn't that work? Oh, because I'm still not. So we talk about zooming in on just the x or just the y-axis, or zooming out. So I need to zoom out on the y-axis here. So did we talk about that? Okay, so on the Mac it's Option and Command. If I hit Option there, you see down in the lower left-hand corner, the zoom buttons are now zooming only on the in and out on the x-axis. And if I hit Command, now if you look at the zoom buttons down there, they're showing that's just going to zoom on the y-axis, in or out. What is it on PC? I think it's Control and Shift. Control and Shift lets you zoom in and out on a particular axis. So I'm going to zoom out on my y-axis. So I'm going to hit Command and then click on the zoom button. And that's a better picture of this graph. Displayed graph. And notice it only gave me the chunk from 0 to 10 of the independent variable like I specified. Okay, so now I want to represent the change in the sunflower's height from between 7 and 9 days symbolically. So how much did the sunflower's height change between 7 and 9 days? You practiced this for your homework, right? H of what? 9? Look at that. H of 9 just told me what the sunflower's height is after 9 days, 59.4, minus H of, capital H. Whenever you use the parentheses for function notation, just get in the habit of using the control. Control 9, not shift 9. H of 9 minus H of 7 is the change in the sunflower's height from 7 days to 9 days. And graphing calculator just gave us that value, 14.6 centimeters. Is the change. Okay, how can I show that on the graph real quick? So from 7 to 9. At 7, here we are. And at 9, here we are. So the change in time from 7 to 9 would be this horizontal line here. That'd be my delta x. Delta t, okay. Fine. We used A to represent t. And then this right here then would be the corresponding change in, I guess, change in h of t. And that value is 14.6. Okay, I'll stick around a few minutes if you've got any GC questions. We got lots more to go though.